Okay, now it's 4 o'clock. I need to get started, okay? I know James or maybe Zoe may come, okay? So let's get started. Okay, first one, let's actually review data type, okay? So far we talk about data types, and the variable can be assigned with any data type, right? A variable can be assigned with any data type. But before you determine what data type, you have to look into what kind of quantity it is, right? And you have to determine the data type. So basically, when we talk about a triangle, if you talk about side 1, side 2, side 3, usually this side numbers should be floor type. Usually they are not integer. Why? Because you do have some triangle like 4, 5, 4, 3, 5, right? But some of them may not be that easy. You may have 1, 2, and this one would be square root of 5, right? So this one can never be an integer, right? Is that okay? Is that okay?
Yeah.
So you have
Yes.
to choose the right data type. Okay, you have to choose the right data type to deal with it. So let's assume that we have a building and floor number. So floor number, what data type it should be? Helen, when you go to a building and there is a floor data type, floor number. So floor number should be what type? Helen, hear me?
Yes.
What data type it should be?
Decimals?
Floor, we don't have decimal type. We only have integer, we only have float, we only have character or string, we only have boolean. We only have 4 type, right? Character, string, boolean, float, and integer, 4 type. So your floor number should be what type? There's no type called decimal.
Float?
Yeah, no, it should be integer. You have to, your floor number can never be 1.5, right? Can it be 1.5? No. Your building, you go to a building, the floor number should be 1, 2, 3, 4, 5, right? Even basement may have maybe -1, -2, right? Is that okay?
Yes.
So how about here if I have a, so Ethan, how about your grade? Your grade, you have A, B, C. So what data type this one is? Right, Ethan, hear me?
Data type.
What? What type? Grade should be character, yeah. Character, or we say code is string. Okay, in Python, string and character the same. Single quote, double quote, triple quote, they all mean string. Okay, so this one is actually a string type. And if we actually do pass, no pass, right? This one should be Boolean type. Okay, Boolean type, true or false. Okay, just a brief review. We finished that. Then let's go back to today's material. Okay, so today last time we actually stopped at the math library. So today we are going to get started for this math library. Okay, so math library, we have this plus, minus, star, slash, double slash. Double slash is the so-called integer division. So single slash means you have A divided by B, you have Q, and here you have B times Q, and you have remainder such as 17 divided by 5, you have 3, 15, remainder 2. Okay, this 3 actually is 17 double slash 5. This 2 is actually 17 percentage 2. This is modulus, this is integer division. Is that okay? And 2 square, we write it down as 2 star star 2. This is the power exponent. This is the base, okay? So that's the way we formulate the mathematical thing, but that's a basic operator. So let's look at this one called quadratic root, okay? Quadratic root. I think Helen probably never learned this one, and maybe also Ethan, you learned this before or no?
That's a quadratic formula.
Yeah, quadratic formula. You learned this or no?
Yep.
Yeah. How about James? You learned this or no?
No.
No, you never learned this one. So I'm going to bypass this one because the majority of you have not learned it yet. Okay. Let me see. Let me briefly talk about it, but I don't make this as a required material. Okay. Let me still talk about it. So let me bring up the item. Okay. So let's new a file. So here, let's assume that we have an equation. We have an equation. We have a y equals a times x squared plus b times x plus c. Okay, so that actually is the equation we have, and we are going to actually solve the equation. So we have one equation that equals y equals ax squared plus bx plus c. Okay, so this whole thing becomes a times x minus b over 2a plus, okay, I'm sorry, plus over 2a, and then this one square, okay, and then here we have c, right? We have originally we have c. C should actually, we have a c over here, right? So this one actually is what? This portion we have, this portion we will have a times x plus x squared plus bx b over a, right? Let me see. B over ax plus actually b squared over 4a squared, right? Something like that, and then plus c minus this thing. This thing would be actually would be a b squared 4a. Okay, so this whole thing becomes a plus x b over 2 square plus 4a actually 4a square. Okay, so here you would have, let me see, it actually is, let me see, actually this one is 4a, okay, 4a, and here we have 4ac minus b squared. Okay, this one actually is like this. Okay, so we can write down, so this one is becoming this. Okay, this whole thing becomes something like this. Okay, is okay? So right here it actually has, it actually is a 4a, and then let's change this sign to minus. Change this sign to minus, it will become b squared minus 4ac. Okay, and this portion we can erase. We erase this portion. So y equals this. Okay. You don't need to take notes. Okay. Later, when you finish the course, you can watch the video, rewrite it again. So here, when we have y equals 0, then this a times b plus b a squared will be equal to b minus 4ac divided by 4a, and this a move to here, so you will have x will be equals this whole thing, take square root b squared minus 4ac 2a plus minus b over 2a. Okay, so that becomes the equation we have. Is okay? So then we can solve the problem here. Okay, So that's the equation we see right here. That's the quadratic equation. Okay, that's the quadratic equation that we see from. That's the quadratic equation we see from here. Any question here? So basically, you try to actually try to factorize and then try to find a solution. Okay, and another way to look at it actually is when you have a formula, and this one is actually y equals a squared plus 2b bx plus c, right? So this line of symmetry equals x over b this, right? That's the line of symmetry. So your minimum will be here. Your minimum is actually this minimum. This minimum actually should be y equals ax plus b over 2a. This b over 2a equals 0 is your line of symmetry. And your minimum should be f of b over minus b over 2a. That would be your minimum. Is that okay? Because that minimum will make this guy as 0, and that will be the minimum you will get. Okay? Any question?
No.
No question? So your equation is y equals ax plus b over 2a squared plus f of minus b over 2a squared. Okay? I'm sorry, not squared, not squared. Because this guy, when this guy equals 0, the minimum will be here, right? So this one is your line of symmetry. So your minimum should be this one, right? Because that one will make this guy as 0. Okay? And it can be maximum if your a actually is less than 0, then this one y equals a x plus b over 2a squared. This one always is negative. So your f of minus a over 2a, that would be your maximum over here. Okay? Anyway, that's actually too far. I don't think that most of you understand it. But here, let's actually try to solve this, okay? Try to solve this. So let's assume that actually we are going to solve this one, and we have that equation. So we would have this actually root. So we would have root 1 and root 2, right? So that before we go for the root 1 and root 2, we need to actually decide the determinant. Determinant equals actually b squared, okay, minus 4 times a times c. Okay, what is that? This one actually is your x equals minus b plus minus b squared minus 4ac divided by 2a. If this one actually is the whole thing is negative, you won't have real root. Okay, you don't have real root. I know some of you don't understand, but it actually represents that your function a less than 0, it never touch the real line, and then a greater than 0, it never touch the real line. So in that case, you cannot find any root. Okay, so here actually we try to do this. Okay, we try to do a equals a float of input. Okay, enter a. Okay, a coefficient. Okay, and then b equals float input of. I know some of you may not understand. It's okay. I just try to finish it for those students who can understand. Okay, but we will try not to drag this one for too long. Okay. So we enter a, b, and c. Okay. 3 number, and we try to calculate the determinant. Okay, so here if actually DET actually less than 0. Okay, so in that case, we do what? Print no real root. Otherwise we'll do this. Okay, otherwise we'll do this part. Is okay? Otherwise we'll do this part. So we would have two roots, R1, root 1, and we can calculate the other one. Actually, that is the symmetry point. That would be minus B divided by 2 times A. That would be line of symmetry, right? That is line of symmetry. So we will have this, what? This one actually symmetry plus what? So we would have root equals minus B plus minus this one, B squared minus 4AC divided by 2A. So this portion is symmetry, right? So we will have plus square root B squared minus 4AC divided by 2A and minus 1, okay? So root 1 would be this one called this divided by 2 times A, okay? And we have the root 2 equals symmetry minus this one divided by 2 times A. There's a 2 root over there, and whatever inside the parentheses should be square root of this guy, okay? So we do mass.sqrt of this guy, B star 2, so that will be our determinant, right? Is it okay? Mass.sqrt, and then here would be the determinant. And here we would need to actually import mass, right? And right here, we should actually put in root 1 equals percentage F, comma, root 2 equals percentage F, okay, percentage 2 root R1 and R2, okay? So this is probably a little bit too hard for some of you, but I just try to finish it, okay? So let's assume that here, let me actually save us. So if you don't know, don't worry, you have not learned the math yet. So chapter 3, I put this one called ROOT roots, okay? So enter, if I have 1, 2, 1, I should have 2 minus 1 as the root. Is that okay? Hello, is that okay?
Yeah.
So that actually is x squared minus 2x plus 1, okay? And it will be x minus 1 squared. And when this equals 0, x should be 1, okay? Double root, okay? We do not detect the double root condition, but it doesn't hurt, okay? You still have this, okay? You still have this. Okay, let's actually try to run again. And if now I have, say, 1 minus 3 and actually 2. The root is actually 1 and 2, right? Because I have x squared minus 3x plus 2. It can be factorized as x minus 1, x minus 2. And this guy equals 0 means x equals 1 or x equals 2. Is that okay? Any question? Okay, so I just show you how to solve this equation, but since some of you have never learned that, so it is okay. We go through it for the math library. So to import the math library, you need to do import math, and then you can use the material in there. So let's try some simple one, okay? Not square root, maybe too hard. So what's inside the mesh library? Let's actually try another one. New file and save as. Here, let's do circle. Okay. Circle. So circle, we would have. So we import mesh. Okay. And we actually do radius. Okay, some of you work on this homework already. It's fine. Okay. So we need to actually take the data floating point type, input, enter the radius. Okay, remember here, usually I like to use a colon and some space. Otherwise, your data will be entered and it will be jammed with the S. That's no good. So usually put this like this. Okay, so we have a radius. So if we want to calculate the area will be mesh.pi times the radius square. Okay, something like this. Okay, and then we should print out the area for a circle with radius, this one is this one. Put your radius over here. Put your area over here. And we can run. Okay, so radius 1. Is okay so far? Any question?
No.
So this one we talk about the square root function, right? Square root function. We talk about the pi variable, right? Pi variable, square root function. So let's try something else, okay? Let's try something else. So here, next one, let's actually try another one, okay? So let's actually have a function called rounding, okay? So save as right here, let's call it rounding the pi, okay? So rounding the pi, let's try this one for x in range, okay? I would like to find x in range, and here I'm going to use starting from 0.9 up to 1.1, okay? Step size 0.1, okay? So here let's do 1.2, okay? 1.2 not included. So let's do this one, okay? So here print. This one should be ceiling of x equals percentage f, okay? So here let's do mesh that ceiling function of my x, okay? And this one I'm going to copy. So here I have ceiling, I have floor function. I have rounded function, okay? So let's save this one. Let's actually save. And that's actually, and after I print these three, let me actually try a different number, okay? Object cannot be interpreted as integer, that's fine, okay? That actually is fine. That's actually started from actually here, 12, and step size 1. It won't hurt us, okay? So here let's actually try to have t over here, and my x will be equals t divided by 10. that actually won't hurt, okay? Won't hurt. I can convert integer to floating point. Let me see. Oh, okay. Let me see. What is that? Sorry. It said that mass is not defined. Oh, I did not import it. I'm sorry. There's no rounding function. Percentage F. Percentage F, I'm sorry. So here, I should put this way. Let's see. Go back to here. Mass library, cosine, row seeding. Rounding probably doesn't need the mass. Okay, let's try this one. Yeah, rounding doesn't need that one. Is that okay so far? But we have how many points? We have actually 3 points. I'm sorry. 3.9 to 12. Oh, okay. It's not 9 to 12. I should start it from 0.9 to actually, I should have 0.9 to 1.2. No, I should have actually 0.9 to 22. Okay, this will give me more points. So it will be 0.9, 1.0, up to 2.1, right? So that makes more sense. Actually, let's run it. Okay. 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 So here show you the function. So let's actually also print x. Okay.
I knew I should do it.
Question? So if the x is 0.9, I will run to seeding 1, floor 0. So basically this 3 function is, I have an x, right? If x is 0.9, it will be run to seeding as 1.0, run to floor as 0.1. So 0.9 is actually seeding is the function that next integer. Is that okay? So if actually is a 0.0, the seeding will be 0.0. The floor is also 0.0. Okay, but if it's 0.1, the seeding will be 1.0, the floor will be 0.0. Okay, is that okay? Hi Helen, are you okay?
Yup.
Yeah, doing okay? So floor function is the largest integer below you. Okay, so floor function also has a name of called the greatest integer function. That means the greatest integer below you. Okay, it's very strange that it is called the greatest integer function, but it actually means your floor, some number that's below you. Okay, so if you do greatest integer function, that also means floor function. Floor function is the greatest integer function. Greatest integer function. Okay, you can check the math. And greatest integer function means the one below you. So the chart would be like this one. So if your number is between 0 and 1, not including 1, okay? 0 and 1, but not including 1, this whole thing is actually 0. from 1 to 2, not including 2, it actually is 1. Okay, so 0.0, that's 0. 0.1, that's 0. Go all the way to 0.9, that's still 0. Okay, 1.0, it becomes 1. Okay, let's go greatest integer function. Greatest integer function means the greatest integer that is smaller than you, smaller or equal than you. Okay, and then this one we call the floor. So you have a floor. You are here. This one is your ceiling. So you are 0.5. 1.0 is your ceiling. 0.0 is your floor. Is okay? And floor, the other name for floor is also called greatest integer function. Okay, ceiling also called the least integer function. Okay, and integer division will give you what? Integer division will give you this function, the floor function. Okay, integer division will truncate all the digits. Is that okay so far? Hello, question? So that's the ceiling and floor function. Okay. Other than that, the exponent, log function, log10 function, log function. I'm not sure you guys learned that yet. Okay, so we will just go through these different functions. When you need a function, you come to here to check. Okay, any question? Any question?
No.
So if here I have, so this one is okay. So let me actually save as rounded 2. Okay, so I save as rounded 2. So I have a rounding 2, and then this one actually I just keep 1. Okay, so here I have an integer of this guy. I run an integer of this guy. So this guy should perform as what? Is this guy equal to ceiling function or floor function or rounding function? Which one? My t from 9 to 22, right? Divided by 10, it should be 0.9 up to 2.2, right? But not including 2.2, so it's up to 2.1. So I use int to convert it to integer. Then will this int be ceiling, floor, or rounded? Which one? Ethan, which one? Hello, Ethan, hear me? Hello, Ethan, hear me? Hear me? Anybody hear me? How about James? Can you answer this one? I don't hear from Ethan. Hello, James.
What's the question again?
The question is that this int function will convert a floating point to an integer, but it is the same as ceiling or floor or rounded.
Could you say that again?
I already said it. I have an integer function that will convert a floating point number to an integer. Using int function. So this int function will behave like a ceiling, floor, or rounded.
Round?
You say round? The answer should be floor function.
Okay.
Okay? So you see that 0.9 is rounded to 0. 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.9, they all round to 1.0. They truncate whatever fractional part you have. Is that okay? So integer function is a floor function. Is that okay? Check this one. It's a floor function. Any question?
Nope.
It's a floor function, okay? And if I want to actually make this guy behave like a rounding function, what should I do? If I want to use this int function, but I want to make it behave like a rounding function, I need to make some adjustment. What should I do?
Integer division.
Integer division? No. How can you divide it to make it a rounding function? So that it can behave like a rounding function. I heard that you know idea. So this integer function actually will have response like this, right? From 0 to 1, they will round it to 0, right? From 1 to 2, they will round it to 1, right? And your ideal rounding function is from minus 0.5 to 0.5, you round it to 0. From 0.5 to 1.5, you actually need to round it to 1, right? So the answer is, if you want to have a rounding function, you should plus 0.5. And that will behave like a rounding function. So let's see. 0.9 is actually 1, right? 1.0 is 1, 1.4, 1. 1.5 becomes 2. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Okay? Any question? That's how you use a floor function, but you want to do rounding using a floor function. Hi Zoe, is that okay? Make sense?
Yeah.
Yeah. So that's when you don't have a rounding function to use, you still can use a floor function to perform as it. Okay. Okay. So that actually is using the integer truncation, but we can perform rounding. Okay. So that part is done. So next one, we are going to talk about factorial. Before we do factorial, let's talk about sum. Let's talk about sum, okay? So this one, let me ask Helen a question, okay? Let me try. So now we are going to do a sum function before we go factorial. So let me actually define a function. The function called sum of n, okay? And this sum of n actually means that it would be equals 1 plus 2 plus 3 plus 4 plus blah, 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 plus 2n. So how can I design this function n so that actually it will take the sum for 1 to n? So Helen, how can I do this one? Giving you an n, but I'm going to calculate these things, 1 to n. So Helen, 1 plus 2 plus 3 equals how much?
6.
6. 1 plus 2 plus 3 plus 4 plus 5 equals how much?
15.
15. Then 1 plus 2 plus 3 plus 4 plus 2, n equals how much? If you know about n, how can you write this down?
It's 1 plus n.
1 plus 2 plus this up to n. Yeah. How about James? Do you know?
Like what I do in like numbers like this, if I know what n is,
Yeah,
then
if
I
you know.
would if then I would add 1 to n, 2 to the number before n,
Yeah,
3, like we would do that.
give me the number here. Give
So
me
I
the
would do
equation. Give me the equation here.
so n divided by 2 times parentheses n plus 1.
Okay, but this equation is correct, but how can we derive it? So yeah, I'm not asking you, okay? So the sum of this one, actually 1 plus 2 plus up to n will be equals n times n plus 1 divided by 2, right? How to derive it? Let's actually erase this part, right? Erase this part. So we will have, let's assume that this guy called S, right? And the reverse of this guy is n plus n minus 1 plus blah, 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 plus 1. So here, sum these two equations together, 2s on the left would be n plus 1 plus n plus 1 plus blah, 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 plus n plus 1. Totally, how many n plus 1? Totally n plus 1. So n plus 1. So this guy equals n times n plus 1. So your S will be n times n plus 1 divided by 2. Make sense?
Yep.
Yeah. Isa, is that okay?
Yeah.
About Zoe, is that okay?
Yeah.
And how can you remember this? Every single time, how can you remember this? Just remember n times n plus 1 divided by 2. How can you remember it? Let's look at the a trapezoidal area, right? The base 1 here is 1. Base 2 here is n. And we actually duplicate the area to make it as a parallelism. So here we add 1, here we add n. So this one is just like n plus 1, n plus 1, n plus 1. Totally the height is n. So you end up with base 1 plus base 2 times height divided by 2. That will be your area for trapezoid. Make sense? Because here you have 1, 2, 3. The base would be n, right? So totally the height is n. Make sense? How do it make sense? Make sense or not?
Yes.
Yes? So Ethan, does that make sense?
Yeah.
Yeah? Okay, good. Then okay, that's good. But how about here? How can I actually use program to sum them up from 1 to n? How can I do that? So here I may need to have a s equals 0, right? For actually I in range. What should I put here? What should I put here? Zoe, what should I put here? Your I need to change from 1, 2, 3, 4, 5, 6, 7, 8, 9 to n, right? So here you should have a sum will be plus equals I, right? And at the end you return s, right? So but here what should I put here? So you sum every time, add the number in, add the number in, add the number in, but the number will be 1 to n. So what should I put in my range function here?
From 1 to n.
digit plus 1.
Oh, n plus 1, yeah.
Because n doesn't, the n plus 1 not counting. But this one, because you can omit the 1, is okay? So
Yeah.
that one is okay. So let's print sum of 5. So 1 plus 2, 5 would be 15, right? Yeah, is that okay? So let's try this one, okay? So the series of 1 equals sum of this, okay? So let's actually save this one. Is that okay? Does this make sense or not? Helen, can you follow? I know you are younger, so can you follow this one so far? Is that too hard to you or no? For
I'm
too hard?
kind of confused.
You kind of confused. Which part? So S1 means the sum of 1 to 1. S2 means the sum of 1 to 2. So 1 plus 2. S3 will be 1 plus 2 plus 3. So it's actually 6. Is that okay?
Yeah.
Are you okay? And Ethan and James are supposed to know this, okay? Supposed to know 1 plus 2n, how to calculate 1 plus 2n. And Helen, you're probably too young for this one, but you still try, okay? Any question up to here?
No.
No? No? How about Ethan, are you okay?
Yeah, I think.
I think it's easy for Zoe, okay, so no problem. Now we are going to talk about factorial. So what is factorial? So factorial is bend, right? Unbend. So factorial means 1 times 2 times 3 times 2n, right? So here let's actually new a file. It's called factorial of n. Okay, we are going to calculate this one. So factorial of n, f will be equals 1 times 2 times 3 times 4 times 5 times blah 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 times up to n. So the structure very similar to the sum. Structure very similar to the sum, except that now it's multiplication. So how can we do this one? Here, let's actually define a function. Let's call this one fact. Fact n. Okay. So how can I do this one? Okay. So for Zoe, how can I do this one? Calculate the factorial. Here we have a sum. So here we should have a product P. Product P started with 1. And then for integer I in range, 1 n plus 1. And then P product times equals your I, and then at the end return product. And then we copy the whole thing over. And here we change this one to P product. And here we actually call factorial. So right-hand side problem and left-hand side problem, how much difference? This one is different. This operator is different. Other than that, it's just name change. And it will work. Make sense or not? Is that okay? Hello, is that okay so far?
Yeah.
Zoe, does this make sense?
Yeah.
And why do we need a factorial? Is a factorial very important or not? Zoe, is that very important or not? When do we need the factorial numbers?
So,
When do we?
when you have a lot of numbers.
When you have a number, when you do combinational numbers, you do permutation, right?
Yeah.
Yeah. Okay. So for James and Ethan, are you okay for this one, factorial?
Yeah.
This one, we are basically calculating the n-band. N-band actually means n factorial. So n-band is exactly the same as n factorial. Is that okay?
What does factorial mean again?
N-band. N-band means n times n minus 1 times n minus 2 times blah, 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 times up to 1. That's called n-band.
Wait, up to 1?
So 1 times 2 times 3 times 4 times 5 times up to n.
Okay.
Okay.
Is that okay? So every time we get a number I and then we time to the product. So initially we have product equals 1, right? Then this product times equals 1, it will still be 1. Then product times equals 2, it becomes 2. Product times equals 3, it becomes 6. Product times equals 4, it becomes 24. Product times equals 5, it becomes 120, right? And then product times 6 equals 6, it will actually become 720, right? That's n-band. That's the n factorial. So James, have you learned this in school or no? Yes or no?
No.
No? Are you going to be 7th grade or going to be 8th grade?
Right now I'm taking 9th grade math.
Yeah, but it's supposed to be taught in maybe 7th or 8th grade, okay? Probably you need to review the number theory a little bit, okay?
Okay.
Okay. So let's see. Let me teach you something in math, okay? So let me teach you something in math. Anyone hear of this one called Pascal triangle?
Yeah.
So though
Yeah.
you hear this, right? Ethan, you hear it before?
I've heard it before, but I kind of forgot.
So you forgot it. How about James? You hear of the Pascal triangle before?
Yeah, I've heard of it.
It's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Right?
Is this a code?
What? Helen, any question?
What does the Pascal triangle do?
Pascal triangle is this one. I'm going to explain it, yes. So this one. So what will this Pascal triangle do? Let's look at it, okay? Let's look at how this Pascal triangle would do. It is very important, actually. Really very important. So let's look at what Pascal triangle will do. You have x plus 1 to power 1. What will be the result? Zoe, what will be the result?
Wait, 2 power 1?
X plus 1 to the power 1. 好，记得
x plus 1 to the power of 0 is just 1.
1. How about this guy?
Then
Right?
x plus 1. Yeah.
How about this guy?
X squared plus 2x plus 1.
How about this guy?
Then x cubed plus 3x plus 3. Wait, 3x. Oh, wait, then 6. Oh, wait, I forgot. Yeah. You have to change the exponent.
So what does this tell you?
So it's a pattern. And then the Pascal triangle tells you what number.
What number you should be, right?
Yeah.
What number should be?
Yeah. And then you just have to remember to change the exponent.
Yeah, you have to change the exponent. Is that okay?
Yeah.
Yeah. So Pascal triangle tell you this. And what does this Pascal triangle do with the pen? What does the Pascal triangle do with pen?
You can make stuff with I forgot. Wait. Yeah, calculus stuff.
Yeah, calculus. Yes. Yeah. Calculus. But actually, you don't need calculus to understand this. Let's assume this, okay? Let's assume this. We are going, let's think about this one. Let's go, first one, you are stay at the original point, right? You can go left or right. Left or right. How many chances you go to right? 1. How many chances you go to left? 1, right? So totally, you actually go left or right once. You have 2 possible cases. One go to the right, one go to the left, right? So if you have the second chance that you let me don't use this one. Don't use left and right. It's actually not easy to explain. That's talking about you toss a coin. You may have head or tail, right? So first toss, you may have head or tail. So you would have one case for head, one case for tail. Is that okay? And then second, you toss the second time. You may have head and head. You have one case that you will become actually one head, two head, right? You will have tail. You have one case. You will have actually tail. You will have head, tail, and tail head. 2 cases that would actually go to the one head, one tail. This is 2 head. This is 2 tail. Is that okay? Hello, is that okay? And if you do third time head, you 1 case, and then 2 head to 1 tail will be 3 different cases. And one head, 2 tail, 3 case. 3 tail, 1 case. So basically, this one equals this one. This one equals this plus this. This one equals this plus this. This one equals this. Is that okay? So to build your Pascal triangle is not too hard. You basically start from 1, 1, 1, and then this one 1, this one plus this one is 2. This one 1. Then 1, this one plus this one 3, this one plus this one 3, this one 1. And this one 1, this one plus this one 4, this one plus this one 6, this one plus this one 4, this one 1. Okay. Then the next one 1, 4, 6, 4, 1. This one 1, this one plus this one 5, this one plus this one 10, this one plus this one 10, this one plus this one 5, this one 1. And that would be the coefficient for x plus 1 to the power 5. Is that okay? Because you have x plus 1 times x plus 1, blah, 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 5 times. You can pick x or pick 1. So the coefficient of 5x will be 1. The coefficient of 4x but 1 will be 5 because of this one. The coefficient for 1x and 4 1 would be also fine. That's this one. Is that okay? Is that okay?
Yeah.
Make
Basically,
sense?
the number. So
What?
basically, the numbers are listing the possibilities of.
Yeah, the possibility of how many tail will happen, or how many head will happen.
Okay.
And to construct this table is very easy. You just get started from, you started from 1, and this 1, 1, copy that one. And this one is 1, this is 1 plus 1, you have 2, 1. And this one 1, this one plus this one 3, this one plus this one 3, 1. And then 1, this one plus this one 4, this one plus this one 6, this one plus this one 4, this one 1. Is that okay?
Okay.
Make sense? Make sense?
Yeah, makes sense. Makes sense.
And it's also not done yet, okay? It's not done yet. So here, 1 is x plus 1 to the power 0. 1 is actually x plus 1 to the power 1, right? So this one actually is also equals C1 pick 1 x plus C1 pick 0 x. And this one also equals C2 pick, if you have x plus 1 square, it will be C2 pick 2 x squared plus C2 pick 1 x plus C2 pick 0 would be equal to this one. So your x plus 1 cube would be C3 pick 3 x3 plus C3 pick 2 x2 plus C3 pick 1 x1 plus C3 pick 0. So your Pascal triangle number is also your combination number. Why? I toss for 3 times, pick 3 head. I toss for 3 times, pick 2 head. I toss for 3 times, pick 1 head. I toss for 3 times, pick no head. Is that okay? I know it's okay.
Yeah.
Make sense?
Yeah.
And
Different like outcomes, right? And then you just add the sum of
yeah. So basically what we learned from here is your x plus 1 to the power n will be equal Cn max n xn plus Cn takes n minus 1 xn minus 1 plus Cn n minus 2 xn minus 2 plus blah 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 plus Cn pick 2 x2 plus Cn pick 1 x plus Cn pick 0. It's okay? I make a simple math to be too complicated, right? But usually, math, you can be very simple, can be very difficult. Just look at how you look at it, okay? For Ethan, are you okay? Can you understand this? How about James? Can you understand this one?
Could you go over what you said really quick?
Yeah, so have you guys learned the combination number?
No. Wait, no. Could you first walk us through it? I've heard the word before, but I don't know if I.
So here, if I have x to the power n, right, it is equals x plus 1 times x plus 1 times x plus 1 times x plus 1, blah, 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 n times, right?
Yep, n.
Yeah, n time. So here, for how many x to the power n? Now, every time I need to pick x, right?
Yep.
When I expand it, every time I need to, then that is the coefficient for Cn pick n, right?
Yep.
And then if I want to try n to the power n minus 1, I have to every time pick 1, except one time I can pick 1. Other cases I need to pick n. So totally it will be n Cn pick n minus 1. Is that okay?
Okay.
Then we need to study the combination numbers. Then we will be able to solve this one. And it happened to be the Pascal triangle. Is that okay?
Yep.
The coefficient happened to be Pascal triangle. So now let's actually look at the Cn pick m. I have 1, 2, 3, 4, 5, right? I have 5 ball. 5 ball. 1, 2, 3, 4, 5 ball. I would like to pick 2 ball. How many possible outcomes? Now, Roy, how many possible outcomes? If I put 2 ball. 5 ball, where I have a 5 ball, 1, 2, 3, 4, 5, and I'm going to pick 2 ball. So it will be 5 ball.
5, pick 2.
2 ball. It should be 10, right? But how comes that I know 10?
And just 5, pick 2.
Yeah, it's 6, 5, pick 2. Yeah. So it actually is a 5 ball. The first ball have 5 choice, right? I may pick 1, 2, 3, 4, 5. The first ball 5 choice. Second ball have 4 choice. But first ball, second ball, it doesn't matter. So I divide by 2. Is that okay? Is that okay?
Yeah.
So this guy actually Cn pick m equals n band divided by m band times n minus m band. That's our factorial, the combinational number. So here, if I have C5 pick 2, it would be 5 band divided by 3 band times 2 band. And that would be 5 band divided by 3 band would be 5 times 4 divided by 2 band would be 5 times 4 divided by 2. That would be 10. Is that okay? I think this is probably too hard for Helen, but other people should be, I would say MCA will have some problem like this, okay? MCA should have some problem like this. The combinational number, you should know about combination number and Pascal triangle. Any question? Let me try again, okay? Let me try again. So here I have 5 ball. Let's don't use 1, 2, 3, 4. Let's pick A, B, C, D, E, 5 ball. Right? I'm going to pick the 2 ball from here. So I pick 2 ball from here. So the first ball I have 5 choice. Say I pick A. Then I have 4 ball left. So the second ball I have 4 case. Third ball I have 3 case. Right? But once I pick A, B, C, C, B, A, B, A, C, it doesn't matter. So I'm going to divide this one, what? I'm going to divide this one by what? By 3 balls combination, so divided by 3 band. Is that okay? So this number is actually 5 band divided by 3 band divided by 2 band. So pick 3 ball is also 10. Is it 1, 5, 10, 10, 5, 1? So pick 2 ball and pick 3 ball are actually the same number. Is that okay? Can you understand this guy up to here? Okay, you have to think about it, okay? You have to think about it. 3 ball A, B, C, they are totally 6 cases. They are totally 6 cases. A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. So total that is the number I divide over here. These 6 cases doesn't matter. Doesn't matter. Okay, but on top I pick 3 ball. The first time I have 5 choice. Second time I have 4 choice. Third time I have 3 choice. And I pick that 3 ball out and I divide it by 3 ball. Those 3 balls order doesn't matter. Is that okay?
Yep.
That's the combination and permutation. Okay, you need these if you would like to try MC8. Okay, they have some problem like this. Okay, make sense? and not related to our what? Our factorial calculation for factorial. Is that okay? Is there a factorial function you can use? I think so. So Python factorial function. Python function is a factorial Python function. No, I don't want to calculate myself. Is it the in library? Mesh factorial. Yes, that's the one we like. There is a function called mesh factorial. So let's actually have this one, right? So let's actually copy this one and pass over here. So this one actually is, I use my own factorial function, but if you actually would like to actually call it from mesh function, you don't want to recalculate it, then you can actually do import mesh. And I will give you a factorial function. So these two are supposed to be the same, but in between I print an empty line. Same, right? Top portion and lower portion the same. Okay? So now you know about what is the use for factorial, right? So Helen, what is the use of a factorial? Can you try to say why we need to have a factorial? Factorial.
Because we don't want to write it.
We don't want to write it. We don't want to go into detail. So I have ABC, right? So ABC, if I actually try to permute it, I can have ABC, A, C, B, B, A, C, B, C, A, right? C, A, B, C, B, A. Totally 6 cases, right? Because the first one, I have 3 cases, A, B, C. Second one, I pick A already, it has 2 cases. So 3 times 2 times 1. Is that okay? Is that okay? First one, I can have A, B, C, that's 3 cases, right? And if I determine A, the second one, I have 2 cases, B or C, right? And if I pick C, B, I only have C left. So actually it's 3 times 2 times 1. So let's look at if we have this one, we have A times B times, I have 4 balls, A, B, C, D, okay? I'm going to look at how many permutation I can get. I will have A, B, C, D, A, B, D, C, A, let me see, A, B, C, D, A, B, C, D.
Would it be 4 times 3 times 2 times 1?
Yeah. It's 4 times 3 times 2 times 1. It will be your permutation of factorial. Is that okay?
Yeah.
So this is A part. A part you have 3 times 2 times 1, right? And totally you have 4. Leading later have A, B, C, D. So totally 4 times 3 times 2 times 1. Is that okay? This is called permutation number. Okay, it's equals factorial. So factorial is to provide the number of permutation for all of your numbers, or all of the possible outcome for the balls. Okay, combination means that the order doesn't matter, and you also need to use the bin to calculate it. And that's why here we spend so much time to look at the sum and factorial. Is that okay? Next one, the limits is of integer. The limit of integer we can try. How about let's try 100 band? Okay, let's try 100 band. So can we try 100 band? So let's actually try 100 pen. Let's try a new one. Okay, so let's just try save as fixed number 2. Okay, so this time I'm not going to call this guy. I don't call this guy. Actually, this time I'm not going to call this guy. So I may delete this one as well. Okay, and here I'm going to try to calculate 100 pen. So I go to 101. Okay, so actually let's save and run. Oh, okay, 100 is good out. Okay, so how about here? I try to 1001. I just want to try the limit of my computer. Okay, so do stupid thing. Go. Whoa, so fun. I think it's 400 now. 500 now. 500, yeah. Keep doing. It will slow down. It actually will slow down. Okay. I don't care what is the number. I just want to see if my computer can still survive. Keep going. It actually doesn't break. Okay. So how about this? I don't care about this one anymore. Okay. I don't care about 1 to 100 now. 1000 now. How about let's try. Just try the big number. So let's try 1, 2, 3, 4, 5. Okay, let's try this one. A huge number. No, let me see. Okay, this one. Let's try this one. I don't care. Okay, this is number 2. We don't care. Go. Oh. Spend a lot of time. You haven't come out yet. Okay. So I try 100K. I try a number really huge. Okay. I just want to try out the big number to see the limit of integer. Okay. Can I get it? I don't think so. It will be dead. I don't think I will get it. So computer would have some limit. You cannot try arbitrarily large number. They are some limit. They are limit because they have disk space. They have CPU time. They have some limitation. It's still going. Okay, you haven't done yet, but I don't think I will get it. I try a real huge number. Too long. Doesn't make sense. Let's actually get it out. Okay. It doesn't listen to me anymore. Huge number. I try something too big. Okay, just one night you can kill your computer. So how can I do it? I actually do this one. Come to here, and I just kill my Python. Okay, where's my Python? Booj, I don't see my idle Python. Booj, Python. Let's kill Pythons. Okay, is that okay? Let's show you when sometimes you actually did something ridiculous. That is too huge. I hit a limit. So let's make a smaller number. Okay, let's try one by one. Don't jump too far. Let's try this effect 2 again. So here, let's actually try 5,000. Okay, let's try 5,000. I think 5,000 may be okay. Maybe okay. Yeah, 5,000 is okay. So let's try 10,000. 10,000, I believe, should still be okay. Any question? Yeah, it's okay. Just keep going. Okay. So 10,000 still okay. Let's try 30,000. I think this one will break. Go. It actually pass. It actually pass. Okay. Look like it pass. Any question? But there should be someone you will give you trouble. So here let me try. Is that done? Not done yet. It's still going. I think it actually too huge already. I don't want to try anymore because that actually just be stupid, just wasting time. Okay, but there should be some limit your computer can no longer handle. Okay. Any question? Hello, hear me?
Yup.
Yeah, hear me? So there got to be some limits on your computer, okay? So let's see. I think it takes too long. You haven't finished yet, okay? But I believe this one should be healthy because it's still going on, but it should be, it's done, okay? It's done now. But I don't want to try anymore because that one would be awfully slow and will not be able to finish. So right here, we actually finish this chapter, okay? So there are some huge numbers. It can keep continue, but it will take a lot of time. But every computer has its limit, okay? So we finish chapter 3, okay? So let's have a 70 minutes break. Let's come back on 5:30. Is that okay? Is that okay?
Okay.
So your time will be say 8:30 or 7:30. Okay, let's get back 7 minutes later. Okay.
I can hear you.
I can
Okay.
hear you.
Okay. How about Zoe? Hear me?
I hear you.
Okay. Okay. Good. So now I think chapter 4 will be huge. I don't want to start chapter 4. So now let's work on some practice. Okay. I'll give you problem and you work on it. Okay. So let's try this one. First question is, can you give me the sum of odd numbers from 1 to 19? Write a program to calculate this one. And then give me even numbers from 22 to 50. Good enough? Is that okay? Give me the result for these two. Use your programming, do Python program and solve these two problems. Is that okay? Work on the odd number first, and then you think about it. Work on the even number 1. Is that okay? Any question? Hello? Any question? Hi, any question? You hear me?
Yeah,
Yes.
Yeah, get started, okay? So, Ethan, how are you going to solve this problem? The first one. How are you going to solve this one?
The sum odds of 1 to 19.
So, how can you do it? If you, what would be your approach to solve it?
Wait, so does it mean like the sum of the odd numbers between 1 and 19?
Yeah, so 1, 3, 5, 7, whatever. So, how are you going to solve it? I'm asking you, what's the method you will use? Yeah.
You could use range.
Yeah, you can use range. Yes.
Yeah.
Okay, so you try, okay? How about Helen? Are you okay? Hi, Helen, are you okay? Hello, Helen? You hear me?
Yeah.
Are you okay?
Yep.
Okay, I'll let you guys do it, okay? And I'll check 5 minutes later. I'll check you. Maybe 5:38. Okay, I'll check your answer, okay? All of you. Just do the odd number for now, okay? If you finish, you are actually welcome to do the even one. But if you haven't, try focus on odd one first, okay? Hey Zoe, are you okay?
My idol still isn't working.
Still don't work? Oh, okay. You have to check it, okay? If your idle don't work, you can use online editor, the reply. Okay. So if your idle doesn't work, you try to find the online editor. If your idle doesn't work, you try to go to. Sorry, my mouse has some problem. So you do replete.it and Python. Replete.it Python here. Okay, so you should be able to work on it here. Okay. Hmm. Okay. Ethan, are you done?
Not yet. I lost Wi-Fi.
You lost the Wi-Fi? How about James? Are you done?
Almost done. 1 second.
Okay. Let me know if any one of you are ready. Okay. Let me check the call. I just want to give you some exercise so you are able to handle it. Okay. Okay, James, are you ready?
Almost ready. Could you give me like a minute or two?
Yeah. I give you 30 minutes of practicing time. Okay. So I'll explain the problem later. Okay. Let me keep my page to the whiteboard, the problem part. Okay, sorry. Okay, who is ready or about ready? We have to move on, okay? We have to show you the answer. So, Helen, are you done?
No.
No. How about Ethan? Are you done? Ethan, can we start with you? Can you share your screen?
I'm not done yet.
Yeah, but I can guide you, okay? Can you show? Because we need to move on, okay? Can you show your screen? I'll guide you how to change, okay? I'll share your screen, okay? Don't
Okay.
worry. Yeah. This is only a practice run, okay? So everybody may not be perfect, so don't worry. So you were up to 20 divided by 2. No, you actually have step size of 2 would be easier. Is that okay? Have step size of 2. And where is your art? You are not summing them. You are not summing them, so actually, number 1, you should use a new program, okay? So here you should have an art equal 0, right? So you should declare a variable called r equal 0, right? Here, every time you come from 1 to 19, that's okay. Up to 20, that actually is okay. Then over here, you should have step size of 2. Every time you add by 2, right? And then your number should be 1 plus, and then here you should have plus equals I, right?
Yeah.
So if I don't check you, you would stay there forever. You are not going to show, right? Because everybody gets started. There are some. The problem is you actually need to what? You actually need to go through a learning curve, right?
Yeah.
100? How comes? Okay, I'll tell you why it's 100. Okay, later. So then actually see James. Can you show me your code? James, can you show me your code? I'll try to help you, okay? No, you print and you only print the number. No, you actually need to, right here. So that means that you don't know what to do, right? And you actually don't know how to do it. It's okay, it's okay. You guys just get started. But you need to learn. Here, you also need to have a sum, right? Your sum initially set to 0. So every time you got an n, and this n, you don't need to print it. You print it doesn't help you. You need to have a sum plus equals your n. And the n running from 1, 2, 3, 4, 1, 3, 5, something, right? And at the very end, you do print sum. Is that okay? Make sense?
One second. So why would sum equal 0?
Sum equals 0 because initially you don't have anything in sum.
Okay.
And then you have the n equals 1, you add the n to sum. N equals 3, you add the n to sum. N equals 5, you add the n to sum. So sum is an accumulator, and at the end of this program, you will sum them up. You will actually get 100. Your print typo. Okay, sorry. Your print has a typo. Is that okay?
But why is it 100?
Yeah, I'll explain later. Okay. How about Helen? Are you okay? Show me your code, and make sure you understand this guy. Okay. Hi, Helen. Show me your code. Hi, Helen. Hear me?
Yeah.
Yeah. Share your code. You need to print some. Yeah. Print some, please. You do print some. And your step size 2, you put 1. Step size 2. Yeah, and its range function is not 0 equals that. N in range function, range, range. Yeah, delete the equal sign. At the end of the line, put column. Run it. Run. Click the wrong module.
Oh, run.
Yeah, run. You have syntax error. Same column, not semicolon. A column. 2 dots. Yeah. Okay. Good. Let me go back to my problem. Okay. So why 100? Why 100? 100. It actually equals this one is the sum of 1, 3, blah, 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 to 19, right? So it actually is the sum of 2i plus 1 and minus 1, I coming from 1 to 10. Is that okay? So it actually is 2 times sum of I equals 1 to 10, and then actually minus 10. So it would be actually 2 times 10 times 11 divided by 2 minus 10. It will 100, 10 minus 10 is 100. Is that okay? Is that okay?
Yep.
Yeah. So let's actually look at it again. So this one actually is, if I say this whole thing actually is I actually starting from 1 to 10, right? So you actually sum up I equals 1 to 10, and then you have 2 times I minus 1. You are summing up this guy, right? It equals actually summation I equals 1 to n, 2 times I minus 10. So this has a minus 10 over there. Minus n over there. And this whole thing equals 2 times summation I equals 1 to n minus n. So it becomes n times n plus 1. 2 cancel with the lower 2, and this one, it equals n squared. So that told you what? That told you, this one told you what? Summation of the R number equals n squared. Summation of the R number equals n squared. I try to prove it to you, okay? Summation of the R number equals n squared. So summation of 1 equals 1 squared. Summation of 1 plus 3 equals, this one is 2 times 2 minus 1, so it equals 2 squared. Summation of 1 plus 3 plus 5 equals 9, is actually 3 squared. Summation of 1 plus 3 plus 5 plus 7 equals 4 squared. Summation of 1 plus 3 plus 5 plus 7 plus 9 equals 25, 5 squared. Is that okay? So summation of 1 plus 2, 19 equals 10 squared. So summation of 2i minus 1, I from 1 to n equals n squared. Is that okay? Makes sense or not? Ethan, does that make sense?
Yeah.
Yeah? Okay, so today you must practice this summation and multiply, okay? I give you some idea. So now next one, you calculate the even numbers, 22 to 50. So what are these? How can you solve this one? 22 to 50. How can you solve this one? So one way you can also use your range function. So range function, this time range function from 22 to 52 increased by 2 because of 52 not included. So you will go 22 to 50, right? And sum plus equals I. Is that okay? That will solve the problem. Is that okay? But you can also do sum of 50 minus the sum of 22, 20. That will also solve it, okay? So let's actually try this one. I'm using mathematical solution. I'm using mathematical solution for this one. I'm not going to give you the code. I just try to use hand calculation. Okay, hand calculation here, I'm going to try, this one actually is, so summation of I equals 2 to 50. That's an even number. I'm sorry, even number, right? That one equal to actually step size 2. It actually equivalent to summation of I equals 1 to 25. And sum 2 times I equals 2 times summation of I equals 1 to 25 and I. So that one actually is what? 25 times 26 divided by 2. And that 2 cancel with this one. Is that okay? Is that okay? That's 50. And 20? 20 is summation of I equal 1 to 10. Okay, that would be 10 times 11. The 2 cancel out. Okay, so it actually is 25 times 36 minus 110. Make sense? Make sense or not? It's 25 times 36 minus 110. 540. Okay? By hand calculation. I don't need computer. Is that okay? Okay, but you can use computer to calculate. See if the number is 540. Okay? So let me actually try to use computer to calculate this one. The second one, you try to program it, okay? So now I try to give you my program. So same thing here. Let's actually do new file. Save as, okay, save as even. So here we have even.py, okay? So we do sum equals 0. And then we do for I in range 22 to 50. 51 is okay, it doesn't hurt, okay? And it's even numbers, so jump by 2. So your sum plus equals I, then you print your sum. So the program itself is not too hard, okay? Not too hard. So that's wrong module. Yeah, it's 540. Is that okay? Is that okay?
Mm-hmm.
Make sense? Let me explain one more time about the math portion, okay? About the math portion, when you have summation of 2i, I from 1 to n, this whole sentence 2 can be taken out. It equals to summation I equals 1 to the n, okay, for each one of these. So here, summation of I equals 2 to 50, 2 times n, right? This one can be changed to, equivalent to summation I equals 1 to 25. This one divided by 2, okay? And I. That would be 2 times n plus 1 divided by 2. The 2 cancel out. So it become 25 times 26. Is that okay? So summation of 50 jump by 2 minus summation of 20 jump by 2. You will get 25 times 26 minus 10 times 11. You get 540. Is that okay? By doing math, not doing programming. So a same problem you can solve by math or solve by program. It's up to you, okay? It's up to you. And either way, you can reach it. But you need to study math so that you can solve the problem, okay? Any question? Any question?
No question.
No question. So you can practice summing something. You can practice summing something like this: 3, 6, 9, up to 48. Is that okay? Some problem like this. Every 3 of them, every jump, every 3 in 1, and up to 50. Is that okay? Practice this one. Is that okay? Any question? Yeah? Any question? No question?
No,
Okay.
thank you.
Thank you. See you next week, okay?
See you next week.
Okay, bye bye.
Bye-bye. Bye-bye.